they should be. It's standard G2. We'll see how far we get, but this is similar to stuff that we've done before. It's just expanding maybe into other functions that we haven't dealt with a lot. So the standard is I can find solutions to the equation f of x equals g of x using algebra and a calculator. And then the extension of that is you can recognize on your own when the function is solvable algebraically and when technology would need to be used. The first thing that you need to do to clarify is what f of x equals g of x looks like. Sorry. Well, almost always it means that you have an equation where two functions are set equal to each other. This could look like any of the following. So you have, 3x minus 2 equals x squared plus 4. Or 3 to the x minus 2 equals 10x minus 2. Or maybe even, the square root of 3x minus 2 equals the cube root of 4x plus 1. Or, 4x minus 1 equals x cubed minus the square root of x. It really could be anything. It's just you see a function set equal to another function. You don't see a y anywhere. Everything's in terms of x. But you have two separate entities set equal to each other. And then we have to decide what that means and how to solve it. The next thing we need to clarify is what makes a function solvable without a calculator and which ones we can solve only with technology. Functions that you can solve with a calculator need to be the same type, and we can also use the word family of function, meaning, let's say, a polynomial is set equal to a polynomial and not a radical. Functions that you need technology to solve include examples below. Okay, so ones like maybe the fourth root of x minus 2 equals the square root of 4x plus 1. They're both radicals, but because this is a fourth root and this is a square root, squaring both sides doesn't solve it, and so we have to solve it using technology. One we had above, 3 to the x minus 2 equals 10x minus 2. This is an exponential, which is a different family than polynomials. Polynomials are like linears, quadratics, cubics, quartics. So two separate families of functions. We would have to use technology to solve that one. Something that looks like this. I don't know. Hold on. Do that. Technically, they both have an x squared. Well, you know what? Actually, that's not a good example. This should be x cubed. This is a polynomial because it's a cubic. This is not, it has a part of a polynomial, but it's not really a polynomial. It's really in the family of root functions because, square root functions, because you have that square root term in there. So we wouldn't be able to solve this one algebraically, at least not easily. So when I say algebraically, that means it's going to be a simple thing to solve or an easier thing to solve. All of these would be very difficult to solve algebraically. And let's do one more. Let's do, the absolute value of 3x minus 2 equals, x squared minus 5x plus 1. Okay, again, we have a polynomial, but it's not the same family as absolute value functions. So because they're not the same family or the same type, we normally cannot solve easily algebraically. All right, so we're going to practice both methods. To solve algebraically, you're going to move everything over to one side and get it equal to 0, just like we've done almost every other time we've solved an equation. To solve with a calculator, you need to... Hold on, I forgot what I was going to put in blank here. Oh, you need to graph the functions and then find the y value that you're examining the function at. make a good window, and find the intersection using the calc menu under second trace. I still think those two words are wrong. I'll have to go back and revisit that. All right, for example 1, solving algebraically. All right, we have f of x as, let's say, 3x squared minus 2. G of x is going to be, let's go 4x minus 1. Okay, the first thing that I should notice right off the bat is that these are both polynomials. One's a quadratic, one's a linear. So if I say find f of x equals g of x, and I set it up that way, 3x squared minus 2 equals 4x minus 1, we've solved things that look like this before because they're the same family of functions. Maybe you want to write that. Same family. They're both polynomials. We're going to solve this by moving everything over to one side and getting equal to 0. So I'm going to subtract 4x and add 1. When I do that, I get 3x squared minus 4x minus 3. And then because we have a quadratic in general now that we're trying to solve, you can either try to factor, or in this case I don't think we can factor, I think we have to use the quadratic formula. So then we do the quadratic formula. Negative b plus or minus b squared minus 4 times a times c all over 2 times a, and then I'm going to simplify. So I have 16 plus 12, which is 28, or 6. Okay, now I know I can simplify that, but for right now I'm going to leave it like that. Now what does this mean? Well, what this means is that your two equations intersect across at these x values. Okay, so there's actually two places where these functions will cross each other, which if you notice, this is a quadratic, this is a line. So it does make sense that this line would go through the curve. If this was a curve, it would actually connect in two spots. Now, why would this be helpful to know? Well, I mean, there's lots of times when you have a real life situation and you have two functions that represent the same situation. We did this in Algebra 1 with systems of equations where maybe you have, I don't know, you're making up a bag of cereal or something, and you have so many pounds of raisins that you're going to use and so many pounds of granola. Because you're making up one thing, you're making up the cereal, you can represent maybe the amount of granola and raisins that you're using. That's one equation. And then maybe the price of each is another equation, and because you have the price and the amount, but they're both talking about the same two items, that becomes a system and becomes something like this, where maybe we're looking to see where the price will equal out with the amount. I don't know. So that's just an example, and I know that was probably way too wordy, but we'll get more into the application of this, obviously, as we go. For right now, we're just working on the skills of setting things equal to each other and solving for x, so that we can use it later. All right, solving algebraically. Let's look at another one. Let's say, I don't know, square root of 4x minus 2. That's going to be my f of x. And let's do my g of x as x plus 1. Okay. Now these are not the same family. One's a radical and one's a linear. But we have learned how to solve algebraically. Okay. So for this, if I want you to find f of x equals g of x, you're going to set it up that way. So square root of 4x minus 2 equals x plus 1. And then if we were to solve this algebraically, you would, to get rid of the radical, square both sides. So you get 4x minus 2 equals, now we'd have to FOIL here, so if you FOIL, you get x squared plus 2x plus 1. And then what's nice in this scenario, because we've done problems like this before, you have a situation where you have a quadratic, and so to solve this, we move everything over to one side, get it equal to 0. Subtract 4x, add 2. And then you either solve by factoring or the quadratic formula. I think in this case, again, we're going to have to use the quadratic formula. Negative b squared minus 4 times a times b over 2 times a. So we get x equals 2 plus or minus negative 8, or sorry, the square root of negative 8 over 2. So really we have an imaginary answer. Now when that happens, what does that imaginary answer mean? Well, imaginary answers mean these two graphs do not intersect. Okay, so for some reason, because we can't solve this one and get x values that work, these two graphs actually do not intersect. And that is possible. So, looks like that one doesn't. Yeah. Alright, example 3, solving with technology. Let's look at f of x equals the cube root of 4x minus 1. G of x is the square root of x minus 4. Okay, now technically they're the same family because both of them are radicals, but they're not the same family because you have square roots and cube roots. So if we were to set these equal to each other, so we have the cube root of 4x minus 1 equals the square root of x minus 4. I mean, we could square both sides, but then that doesn't get rid of my 3. We could cube both sides, but then what do I do if this is a square root? It doesn't cancel. So there's not an easy algebraic way to solve this problem. So this would be a scenario where, because you can't solve for x easily, we're going to graph. Now, when you graph, under y equals, you're going to put one of the functions. So the cube root function of 4x minus 1. And then you're going to also plot the square root function of x minus 4. Okay. And then we want to set a good window, so I'm going to make it a standard window. And there's one graph. I think that's my cube root function. Okay, so you can kind of see, hey, there's my square root, there's my cube root, but I can't see where they intersect, but I'm thinking they will intersect eventually if I stretch out this x-axis. So I'm going to go ahead and stretch out that x-axis by maybe going to 50 and seeing what happens. Okay, so there's that. Okay, so even though it's hard to tell, like I don't want you to count tick marks here, you can see that they do cross. As long as you can see the place where they cross in your screen, then you're good to find it with your calc menu. So we want to find that place where it intersects, because like all these answers mean here when you're setting two functions equal to each other is, where do these two functions meet? That's the solution. So we're going to find where these two functions meet, and that will be our solution to this equation here. To find that, we're going to go to the calc menu, and I want to find the intersection of these two. Now, this one's nice because there's no left bound, right bound. It says first curve. It's going to automatically select one of the functions. You hit enter. It's going to automatically jumps to the second function. You hit enter again. Enter one more time. And it gives you the intersection point. So your intersection point, or the solution here, is going to be where x equals 25.937. x values that would make that equation true. Okay? All right. Now, example 4, I'm going to star, and I should have labeled this one with a 4. Oh, that one's not a 4. Because we're going to probably practice this more tomorrow and Thursday together. So we'll do example 4 together on one of those days. But the important note at the bottom that I want to make sure you get is when you find the solution, you are finding the independent or the x value that makes both equations true. And so when I say solution here, I'm talking about the place where they intersect. So the solution or the intersection, you're finding the independent x value that makes both equations true. Now, we haven't applied this to any type of real-life problem because I don't think that's actually part of this standard. Nope. But we will need that skill later on for other standards, so it's important that we're good at recognizing when do I have to use technology, when can I do it by hand, and then be able to actually do both of those things, solve by hand and then use the calculator. And that's it for tonight.